All right, question 15. Every student's favorite question, similarity and SOHCAHTOA without numbers. In the diagram below, triangle ERM is similar to triangle JTM. Which statement is always true? Which statement is always true? Whew, okay, let's check out, well, all right, it's SOHCAHTOA problem. I've got right triangles. I've got cos and tan over here. Let's write out SOHCAHTOA. Maybe I'll zoom out on this a little bit because there's going to be kind of a lot of referencing things for this question. All right, I'll write out so, and I'm going to actually do so like this. SOHCAHTOA. All right, cos of J. So cos of J should be, cos is ka, adjacent over hypotenuse. Here is the adjacent for this. Hypotenuse is here. So it should be Jm over Jt. Here they say, well, what's going on? I've got the sides from the other triangle, in here. Well, that's just them trying to trick you. These are similar triangles. So even though the sides aren't exactly congruent, the fractions that the sides make will be equivalent fractions. For example, maybe I could put in, I don't know, 3, 4, 5 for this smaller triangle, and then for the bigger one, this side could be 6, 8, and 10. And if I took a fraction of my adjacent and my hypotenuse over here, it would be 4 over 5. And I took, well, with the corresponding angle, adjacent and hypotenuse, 8 over 10. These are not equal. Well, these individual numbers are all different, but these fractions are equivalent. If I say 4 over 5, and I'll just show it to you with a calculator in case you don't believe me, 4 over 5 is 0.8. 8 over 10, hopefully you can do that in your head, that's also 0.8. So even though the numbers aren't the same, if I get the right sides, the corresponding sides, the fractions they make are going to be the same, which is how we're going to answer this question. So cos j is supposed to be equal jm over jt. Well, j corresponds with e over here. So this should be, let's see, ME adjacent, it should be ME over hypotenuse RE. RE. They have RE on the bottom, but RM on the top here. That's not my answer. Okay, let's take a look at number 2. Cos of R. Cos of R is up here. Maybe I'm going to cross off these numbers so it doesn't freak you guys out. We're not using numbers, we're using the letters that are here. That was just for an example. Okay. So cos of R, that means I'm talking about this angle, which corresponds with t. These are really the same thing. Cos of R should be adjacent, now RM over RE, which if I do that in the similar triangle, it would be adjacent over hypotenuse TM over TJ. TM over TJ. And looking at this, they have, ooh, close. They have JM and JT. They had cos of J down here, but still, that's not my answer. This is not right. This is not right. This was, by the way, option 1 and option 2. Option 3, tan of T. So now I'm talking about this. Tan of T is equal to, well, that's RM, and I'm not going to write everything out again. Let's just see. So that's the same thing as tan of R. It should be opposite over adjacent. It should be ME over RM. Opposite ME over adjacent RM. ME over RM. We have RM over ME. I wanted ME over RM. And they're saying to us that it's Rm over Me. Well, let's check number 4. Hopefully that one's right. Otherwise, I'll be re-recording this video. Tan of E. Uh-oh, what happened to my camera? Come on, let's go, boy. Tan of E. It looks like they're switching it every time. It's T. So tan of E corresponds with tan of J. And it should be opposite Tm over adjacent Jm. So it should be Tm over Jm. And because that's opposite over adjacent. And look at that. That is an answer that fits in right there. I am happy. I'm satisfied. The answer here is number 4. This statement will always be true.